Uh, Hello student, last class I started with the C-band. What we can do with the C-band, this I started on the last class, right? We can do some various statistical related graph in the C-band which you cannot do in the matplotlib. Okay, so today I'll show some example of the graph how can you do in the C-band. So first we have to call the library import cbird as SNS, then import panda because we are creating the data frame. After that we'll visualize those data using the cbird. So we have to call also the panda, import pandas as pd. Then data, we are storing some data in x, some values are there, continuous value, and y some continuous values are there, and there is one column. Then that column the categorical values are available, a b like this way. Suppose in a suppose x, this x and this y for some female, and the second x second y for male, uh, like this way. Okay. uh, right. So these are the categorical values. So if you want to plot the x and y graph with respect to the categorical value, suppose for a what will be the x and y relationship, for b what will be the difference between x and y, this one we want to plot. So this is the third column, right? With this, with the third categorical column we need to plot the x and y. So how can you do this thing? So as an df, if you create the df is equal to pd dot data frame, the data frame will be created, and will be created. And now the SNS dot scatter plot, if you want to draw the scatter plot, SNS dot scatter plot, and the x is equal to, always I told, and last class I also told what is the how to write the syntax in the for a cbird. You have to pass the x value, y value, and the data frame also you have to pass through the plot. The scatter plot, x is equal to x, the column name as x. So in this example the column names are x, y, and hue. This will be different column name. Okay. So x is equal to column name, y is equal to again column name, hue is equal to the third, with respect to that hue, third column we want to plot. So hue is equal to the third column name, then data is equal to data frame. PLT dot title, the title will come, and the PLT dot x label, x axis, y axis label will come, and PLT dot show, the graph will appear. Right. So you can see these two y values as well with respect to x for a, and these two are y value with respect to x for b. Like this you can distinguish the y values for different category. So the same way, if you want to load first the data set without creating your own data set, if you want to load the data set, how can you do? So SNS dot load dataset tips is a the data that is already available under the Python. So SNS dot load dataset, and tips, the data frame name is the tips. In this data frame there will be the columns, the total bill, and y column will be there. So SNS dot scatter plot, x is equal to the column, y is equal to the tips column, then data is equal to tips. The data frame name is tips. So you can see the total bill tips versus total bill graph in the scatter plot, in the form of the scatter plot. So first you have to load the data set, then you can call the x value, you can import the x value and y value in the scatter plot. So already I told the scatter plot. I want to plot the continuous two numerical value. To visualize the two numerical value, you can use the scatter plot. This already I told. So line plot, just you want to see the how the how how the y-axis is relates to x-axis. What is the relationship between y-axis and x-axis? To find the relationship, how it is exponentially varying or it is linearly varying. If we do the scatter plot, we cannot easily understand what is the relationship between the y-axis and x-axis. The Using live plot you can do. Okay. Uh, so the SNS does line plot. The X value you can call, Y value you can call, then you can write. So here we are not getting any data from this simple X value and Y value. X is equal to X value, so Y is equal to Y value. But instead of scatter plot, you have to write line plot. But in case of the MATLAB, it is like a plot only, not line plot. Histogram means normally the last lecture I told histogram. If we see the frequency distribution of the numerical data, how the all the numericals data are distributed. Suppose here you can see in this graph, 12,000 data are in the 40 times. So 16,000 data. The value of the data is 16,000, 1,600. This 1,600 is in 50 times there. Okay. So this is the frequency distribution of the graph. So for that you can use the data histogram. Suppose you are creating some data using the random variable, random function, random dot random, 1,000 data you are creating with the random variable, random data, 1,000 number of random data is created. Then if you were to write the hist data, density to means this the density will be there. Okay. So you can see, suppose -3 data are in the few -3 data are available. Zero number of data are more. From 0.4 density of zero data is there. Like this way, you can see box plot. Now the box plot. Box plot is for any column. You can see the box plot. Box plot normally, if you want to visualize any column, which it is any external values are available or not. For that, you can see the box plot. So there are suppose 8 columns. How the 8 columns are the distributed in a range? Okay, is there any range in the which is not in the relevant? Suppose the temperature range should be 20 to 30. If the temperature column, if any values are available under the 50, the 50 temperature is not relevant, right? So maximum data are available between the 20 to 30, but some data are related in 50. So you can identify any outlier. This is called the outlier. To identify the outlier, we used to plot the box plot. So A, B, C, 3 columns are there. Suppose in a data set. So if you box plot, if you data is equal to data, if you write, so all the 3 columns you can see how it is distributed. Suppose the A is distributed from 2 to 4. So some one data will be in 5 and one data will be in 1. No other data in between the 10 to 14 like this way. So if any data is available in column A and 10, then you can identify here. The plot will be like that. Some extra different plot you can see. So you can identify this one. So in box plot you can write particular column name also you can write, or you can entirely draw the graph. All the column you can draw. So in the outlier is there, suppose you can see in the A column 1, 2, 3, 4, 5, there is a data is 30. So this 30 is not relevant to this value. So if you plot the A, you can see this is the one dot is there in near 30. So this is the outlier. Like this one B also you can see there is one value 28. So it is appearing here. You see there is no value in between the after a 10. Okay, so the C there is no outlier is there. Okay, the pair plot normally in a column. If suppose the 4 5 columns are there, right? So if you write the pair plot, each and every suppose A B C D E columns are there. A versus C, A versus B, A versus C, A versus D. Okay, like this you can again the B versus A, B versus C, B versus D, B versus E, B versus B. Like each and every column relationship you can see if you write the pair plot. when you draw the A versus A, so you can see like this. So this is the own graph, own axis versus own axis, A versus A, B versus B, C versus C, D versus D, like this way you can see. Okay, at a one in a one window you can see all the relationship in pair plot. ABC is there. So A versus B, A versus A versus B, A versus C, B versus A, B versus B, B versus C, C versus A, C versus B, C versus C. Like this way, we can identify, right? Okay. So they again the three, one is a categorical value, A, B, C, three values are there. One is a categorical value. With respect to categorical value also you can see. So here the pair plot DF comma hue is equal to D. We can write. So here A versus B, A versus C, A versus A versus B, A versus C for the different categorical D, where the category is male or female. Okay, suppose in this hue, the hue is equal to D you have to write. So that's a different color you can see. A versus B also, these two distributions are there for A categorical value and for B categorical value. So like this way you can see. The one is a Seaborn heat map. So this the pair plot you have done the each and every column the in the visualization from you can see the relationship how the A relates with the B in the visualization from. In the heat map the correlation you will get a correlation between correlation value will get from between A and B, and this value you can see in a graphical form. Okay, suppose total bill versus tips, total bill versus size. How if the value is near to 1, that means almost both values are correlated highly. The total bill both will be the same, they will get 1 here. Total bill versus tips you can see there's a moderately correlated. Okay, so some moderate value you are getting. Here you are getting less value. Total bill size is not correlated, there's a less value you are getting, like this. So if you want to see the correlation value between the each and every column, so for that you can, and after getting the correlation if you want to visualize, for that you have to use the heat map. Suppose you have loaded the data, tips is equal to SNS load data set tips, then correlation tips dot correlation. So if you execute this one, only the correlation value will get. Okay, so total bill how much value is there, correlation value. So again if you write SNS dot heat map correlation, this one if you are passed through the heat map, then you can see in the visualization form. Okay, then plot ratio. So if you want to see the correlation between the visualization form between the two multiple columns, so for that you can use the heat map. This is also necessary to identify which attributes are uh, used for getting the predicting something, or if extra values are there, you can know which values are relevant, which values are significant for predicting something. For that purpose, you can use the heat map. So next class I will discuss some other thing. So up to this I have discussed. So please like, share and subscribe my channel. If you need any comment, anything, you just write down in the comment section. Thank you.